Hello, good morning, everyone, or good afternoon or good evening, depending on where you are in the globe. And we would like to welcome you to another webinar by the Asia Pacific Society of Computers and Education. So this morning, we are very glad that we have a speaker who would actually discuss about breaking the barriers in the learning aids development for the visually impaired and the blind. And I'm Mary Talandron Felipe from the Philippines, your moderator for today. And it is my honor to introduce to you our speaker, Dr. Aaron Raymond C. So let me just give you a little bit about our speaker this morning. Dr. C is an associate professor in the Department of Electrical Engineering at the Southern Taiwan University of Science and Technology. He is currently the Director of Student Affairs in the Office of International Affairs, but his research interest is on assistive device design and development, biomedical image and signal processing, engineering education, and haptics. He has presented numerous keynote speeches on engineering education transformation and assistive devices in the Philippines, India, Indonesia, and Thailand. Dr. C was actually born in Manila, Philippines, and received his Bachelor of Science in Electronics and Communications Engineering from De La Salle University in 2006. He then obtained his master's and PhD in Electrical Engineering with major in Biomedical Engineering at the Southern Taiwan University of Science and Technology in 2010 and 2014, respectively. Subsequently, he did his postdoctoral research in neuroscience at the Brain Research Center, National Tsinghua University in Taiwan. And he also received training on designing student-centered learning from the Olin College of Engineering in the USA and training on game theory from the Warsaw School of Economics. So without further ado, I would like to present, please help me welcome our speaker, Dr. Aaron Raymond C. Dr. C, the floor is now yours.
Thank you so much, May, for that wonderful introduction. And good morning, everyone. And thank you for joining today's webinar. And I really appreciate that for your presence. And let's see today how we could break the barriers of the learning aids development for the visually impaired and the blind. Okay, let me share my screen. Is my screen clear, everyone? Can everyone see the presentation?
Yes, okay. Dr. C, we can see your screen. Thank you.
Okay, thank you so much. I'd like to thank all the organizers for inviting me for this webinar. And I would like to introduce myself in a short while. But today, I would like you guys to think about something that maybe many people are not really looking into. How do visually impaired students learn? Okay, many may have an idea. Oh yes, we have a special education school, and then they have these books in Braille and so on. But the challenge here, there are actually a lot of different challenges on the development of the books that they had, on the education materials that they are using, and so on. And I believe the viewers today many are from computer science background. You may be thinking, how can a computer scientist help in developing teaching aids for the visually impaired and blind? So today, my title for this presentation is Breaking the Barriers in the Learning Aids Development for the Visually Impaired and Blind, showcasing the Tactile system. So a while ago, I already gave an introduction. Again, I'm Dr. Aaron Raymond C., and I'm very glad that I can give this talk to you this morning. So today, I'll be going into several portions. First would be the current situational analysis. So what is the situation of visually impaired and blind, not only the people, but also the children, the students who needs our assistance? Next is the problem statement. What is actually the problem that we are trying to solve today? And then I'll show you the tactic system. And then afterwards, I'll dig deeper into our future plans and applications that we hope could help break the barriers in the development of learning materials. And later on, lastly, I'll conclude by sharing who are we partnering with right now. So to start with, visually impairment is actually a global issue, with more than 2.2 billion people around the world who are visually impaired and blind. Now, you may be wondering, this is a huge number. This is more than like 1/3 of the whole population. But let me clarify something. When you talk about visually impaired and blind, not everyone is blind. Some of them would just be visually impaired. Like, for example, they would really rely on glasses for them to be able to read. Some of them are short-sighted, far-sighted. Some of them can only see from the peripheral view. So here, what you're looking into is like, this is a very huge population. And here in Asia right now, in Asia alone, East Asia, 6.2 million. It's actually higher right now. Southeast Asia has around 78.5 million visually impaired people, and so on. So these are just looking at the blind people. But if you're talking about the visually impaired, it's a very huge number. So they may not be totally blind, but they have a hard time reading through things that we normally read through. So currently, out of this 2.2 billion people, there are 237 million people who have moderate and severe vision impairment. 237 million people. If you look at, for example, I'm originally from the Philippines. Our population is more than only 100 million. That's more than twice the whole population of the Philippines. So this is like a very huge population of people who have moderate and severe visual impairment. Places with a lot of visual impairments, many are in India and China. This, I believe, because of the population. But what is more important that we need to see here right now is how much is lost. Here we could see that the productivity loss is at 237 billion US dollars annually. So this is a very huge loss in terms of productivity. Aside from that, there also is a need of 14.3 billion US dollars to support these people. But the question now is, this loss in productivity, is there something that we can do about it? Is there anything that we can do about it? This is something that I want you guys to also to think about and to look into. So out of the population that we mentioned a while ago, more than 19 million people, more than 19 million children around the world, age 15 or below, have visual impairment. 7 million of them experience severe visual loss, and 12 million could have had this correctable refractive errors, but then many may not have a chance to be corrected at all. So if you look at this population, this is a very huge population in terms of children who needs education. And if you look at it, what is the biggest challenge that they have right now? Biggest challenge by these children is that they want access to information. Yes, today we may be saying that, yes, visually impaired children and people, they have their smartphones, they have their iPhone, because right now iPhone is the best tool for the visually impaired and blind. But aside from audio, they would desire something more. They want to have access to something that they could learn, they could touch, they could read on their own, instead of just like listening all day long. This is something that we're also going to look to in a short while. And then let me introduce to you first, what are the current methods that are being used in terms of teaching the visually impaired and blind? I believe most of you know about the Braille. So this is the Braille system. So there's the 6 dots, and also there's currently the 8 dots system for the Braille. So this is how they learn the ABCs and the numbers in terms of reading on a book. This is like the Perkins Smart Braille printer, when they can type, and record or take down notes. And there's also this specific printer, a tactile image printer, wherein they could print some graphs maybe. But this one is actually still a very challenging method of developing the new information that they needed. So aside from that, there's thermoforming samples where you use plastic so that you could produce 3D images, and we also have 3D printers right now. And there's also a 3D refreshable display sample, and so on. So this one is a multi-array Braille with corresponding tactile graphics. So you can see that yes, there are a lot of these different methods right now. Okay, but how are we going to simplify maybe the development? Because if you look at these different methods, right now, most of the developments are done manually. But how are we going to make it much simpler? How do we break the different barriers that they are facing right now? So these are like new developments where there's like the electric elastomer Braille device, there's this Braille cursor, there's electromagnetic based Braille, many of which would need very small actuators, very sophisticated hardware to make it work. Okay, so here are the existing problems. First one is it's expensive. The Braille books are much more expensive than the books that we are reading right now. So in terms of development, you would need at least 15,000 US dollars to develop a new set of books, and you'd need at least like 300 to 500 US dollars to reprint that book. So it is expensive. Right now, we're working on developing like learning aids. And if you are going to print a page of Braille book right now, it would cost somewhere around $100 NT, or that is somewhere roughly around 3 US dollars. And if it's going to be colored printed or like something more sophisticated, it's much more expensive. And with images and words, that's going to be around 400 NT dollars, somewhere roughly around more than 10 US dollars. So if you think about it, that's per page. You know, at 10 US dollars, it's almost close to buying a book already. So it's very expensive to develop these materials. Number two, it lacks customization. Okay, because it is not easy to develop those books. Those are special books. Once it's developed, that's it. You want a customized, you want a supplementary educational material, you have to make it on your own. And not the publishers won't even, bother to help you make any of those. Before I tried to approach a publisher, actual publishers, and the first thing that they would ask, okay, how many copies are you going to print? If it's less than 1,000 copies, I'm sorry, there's nothing to talk about. So if you think about it, there are some things that that they may want to have. They may wanted something to customize to what they wanted to learn, but unfortunately, it would take time to make one for them. Another thing is that the unique preference, because in terms of the visual impairment, different children, different people would have a different level of visual impairment. Some of them can see in one eye, of them can barely see things. So you see that there's different unique preferences. So once you are developing, how would you know the preference of one child from the other? And then last problem that I would like to share is that our SPED teachers, our special education teachers, could be very good at developing these materials, could be good at teaching and taking care of the children. The sad thing is that although we're living in this very advanced modern time of society, we have AI, we have 3D printing, we have a lot of different technologies that seems to be very high tech. But I'm not sure how many of the special education teachers can use AI. How many of them can really have the time to learn 3D printing and so on? There are a lot of different modern methodologies that are available right now. But the challenge is they may not have the time, they may not have the skill, they need to focus on the children. So these are like issues right now that we're facing, that yes, we're in a modern world, but the methodologies that are being used right now are still what has been done for the past few decades or even centuries. So that's why we came with this Haptics system. So the core technologies, just to give you an overview, is like we wanted to make use of cloud computing. Okay, we don't want the teachers to try to code themselves, that for them to think of like, okay, how do I write a program? How do I do this editor? Let's skip all those kind of things. We also need to have the web and mobile app development. We have a database management, image processing, computer vision, deep learning, and 3D reconstruction. So if you think about all these things, how do we make use of it? Okay, so these are like 3 of the current products before I start into the details. So this one's a TAC card where we develop flashcards. We can develop flashcards where there's the image and there's the words. If you imagine when we were young, when we were still trying to learn words, for example, we have a card and it says apple, A-P-P-L-E, apple. So we have the word apple and we have the picture of an apple. For us, yes, we can see that. Yes, we understand. Well, we can see and enjoy, okay, this is an apple. Okay, this is a ball. This is a tree. But how do you show that to a visual impaired kid? How do you show that to a blind kid? Right? So So this is like a challenge that yes, we can enjoy that, but how can we just make it quick, convert it so that they could see and feel the images that you and I can enjoy normally. Another thing is the tech map. This one is, I think, one of the things that the visually impaired and blind children love when we tested it with them, because they are able to feel for example, how does Taiwan looks like? And then, oh, I didn't know that this city, like for example, this long city over here, wow, Hualien is a long city. I didn't know that before. For example, you're letting them to be able to feel, to understand the geography of the country and so on, and also tag puzzles. So the system we have here is like, we could use a mobile phone, you could use our website, and everything, all the conversion is done on a cloud. And afterwards, we can already have the STL file. We can use a 3D printer, but right now we also have a different type of printer. So we have either 3D printer or 2.5D printer. So these are things that we could also share with you in a short while. So what happens, for example, is like they could do mobile phone application where you could do a photo taking. So it's like there's an image. They could take this picture of the image that the phone using AI TensorFlow could understand or could detect what is that object. So they could also help assist in like, okay, where am I targeting the right object right now? And there's also a selection if it's the teacher or the student who wants to take a photo. So we have embedded object detection. We have a suitable UI for the visually impaired and blind children or teacher, or if it's going to be the teacher, or if it's going to be the parent. We're also using natural language processing and haptic and text-to-speech feedback. So aside from that, we're also trying to, we'll also have our website. So we could just use the website to do the conversion, which I'll show you in a very short while. So we're making use of Amazon Web Services right now to do as our platform for AI cloud computing. So what we have here is that we have the Docker, where we place our tactile processing. We have the processing repository, and also have the modeling repository. The thing here is that because what we do is not just convert the images, convert the words, we also try to combine this and convert it into a printable file. So how many of you are using Facebook or IG? So I believe most of you have tried using Facebook or IG. So if you have used Facebook or IG, then I can just teach you how to use our system in 30 seconds. So it's very simple. It's like a drag and drop image here. You can browse the image, and then you could choose what type of material you're going to produce. Like for example, a tag card. You have the language, English, Chinese, or you want it in Japanese. The size, it could be A4, it could be the B5, and so on. And then we can write the object name here. So like we could type, okay, what's the object? Or we could use the mask. If you want the AI to detect what that object is, this one is still continuously being developed. And usually we type, okay, what do I want to place? Or what is the caption there? And then you just click submit. So just to give you an overview of what we wanted. So over here is like we have the image capture. We capture the image, we pre-process the image, and then we mask the image. Another one is like we do AI object detection and segmentation. So after that, we combine the masked image, we initialize the pixels, we do our surface reconstruction, okay, and then we put it and prepare it for combination. The other part is like after that the object's detected. So now we know, okay, this is a dog, a picture of a dog. It's a DOG. So we have to use NLP, natural language processing, to convert it from the English text or the Chinese text into the Braille counterpart. So now that we have the Braille pixel initialized, we have the surface reconstructed. We combine this together and we have our tactile educational material. So over here, they will have this image of the dog with the Braille DOG on top of the image. So just to give you a more detailed example, so here is like import this photo of this cute cat over here. We do feature extraction, object detection, and then do the Braille conversion, instant segmentation, and then convert it. And then this is already an STL file. And then once you print it, it would look like this. So you have the image of the cat over here, and you have CAT over here. And this could be as fast as just 34 seconds in terms of conversion. Instead of you drawing it, I don't think you could be much more faster in terms of like drawing it and making it. So I think this one is very fast already. And then it would take somewhere around 2 minutes usually to convert the files. So what we have here is like multi-scale pixel feature extraction. We have the shape extraction, and also we make use of natural language processing as mentioned a while ago. So after we convert the images, just to give you a run through, we are trying to have the point cloud information. We use surface pull, surface selection, and then we do 3D reconstruction. Traditional methods would make use of triangulation, decimation, and retriangulation. This would consume time and also a lot of memory. So what we have here right now for the TACPIC is that we can create up to 3 times larger models for the same storage needed, and we are 10 times more efficient in terms of computation and storage on all image sizes. So here is like to show you some samples of a VIB student using the tactile flashcard. So this one's a triangle, we have the car, and then over here is like a VIB student is trying to make use of our tactile map. So here over, you could see like a different products after the conversion, then you just print it out. This is like one of the methodologies that we could do to provide the materials. So this image conversion method for developing tactile learning material currently is patented. We have a patent here in Taiwan. So we just recently received it last July 21 for the patent. And this actually answers 2 of the UN SDG goals, which is number 4, quality education, and number 10, reduce inequalities. Now you may be wondering, in terms of reduce inequalities, aside from educating the children, we are also looking further of how are we going to develop vocational training materials for the visually impaired and the blind. So we have done a visual impaired testing so for the materials, and let me share a video to you.
Visual impairment and blindness greatly affect the different aspects of the lives of the people in terms of mobility, safety, context awareness, and education. Researchers in the industry and academia mainly focus on the development of assistive devices to help for mobility. However, the educational aspect for the visually impaired people is often overlooked. Education of the visually impaired people is important to provide a sense of independence and gain knowledge like any other person. For VIB students, the common avenue for their learning is usually through different learning materials, such as audio interfaces on computers and tablets, Braille text on paper or books for reading textual information, and everyday objects used as a tool to provide information about shapes. These are important tools that can be used by the teachers of the visually impaired.
I'm sorry for the video. Sorry, let me share the video again.
Computers and tablets, Braille text on paper or books for reading textual information, and everyday objects used as a tool to provide information about shapes. These are important tools that can be used by the teachers of the visually impaired. But this approach may engage the students less. To get students to be active in class, creative teachers use different tools such as self-made figures or images to better fit the students' learning habits. Instead of the same handouts for everyone, they have personalized materials for each student, which is a daunting task to design and create as a teacher. But this is the type of teaching that is needed in the special education schools. Introducing the TACPIC system. The TACPIC system is an AI-driven tactile educational material generation pipeline that is interfaced on a mobile application and deployed to the cloud. It takes our algorithms about 2 minutes to generate a single design of an educational aid. These algorithms emphasizes the shapes within the images using a framework called MaskRCNN. This is a convolutional neural network model that takes it a step further by computing not only the bounding boxes of the objects, but the masks that borders the objects itself. By adding our natural language processing, we are able to process Braille labels on top of these masks to tag each object within the image. Finally, through our image processing algorithms, we augment the necessary features within an image to provide important details. The tactile educational materials are automatically generated based on the given parameters set by the user. Inputs from a camera would be able to produce different types of tactile educational materials set by our algorithms for tactile flashcards, tactile peg puzzles, and tactile maps. Tactile flashcards are educational materials that are composed of Braille labels and the shape outline of an object. Geography tactile maps are generated by creating the different cities and segments of a map and labeling the cities within them. Tactile peg puzzles are shape pieces with corresponding holes to be placed in. Algorithms generate STL files of these tactile educational materials so they can take shape with the help of 3D printing. Through the Haptics system, the teachers are empowered with the capabilities of generating new kinds of tactile educational materials without the additional work entailed to create these for the VIB students.
Okay, so that was the video of the Tactile system. Now you have a better understanding of the current version of the Tactile system, which we are also continuously trying to improve. So as I mentioned a while ago, we're looking into not just use for education. We're developing for future for tactile books, tactile menu. So if they go to the restaurants, we could easily produce some of the menus quickly converted into something that they could also read on their own. Tactile floor plans, where in terms of like we go to a hospital, into a building, or in the airport, there may be some of these applications right now, but how are we going to make it much easier to be acquired? And of course, safety guidelines. For example, if you take the airplane, remember that there's this safety manual in front of every seat so that you can read it to know about the safety rules. But have you noticed one thing? Those are just made for us who are sighted. So if you are visually impaired and blind, then we may want to have a converted version of that one. Okay, so over here, you can see that we're looking into different ideas right now. Like, for example, this is a menu, and how we're going to convert quickly this menu and prepare it for the stores and restaurants. So this project has actually won numerous awards here in Taiwan. So this one is the Macronix Golden Silicon Awards. This one's the German Embassy's Falling Walls Lab, and also have the Taiwan Innovation Expo, Social Innovation Award, and Social Entrepreneurship Award. So in terms of this development, we're looking into not just developing it for research sake. We also currently have this Youth Start Plan for Innovation and Entrepreneurship, and we already started our own startup company. Yes, although we're still a startup company, we are already pushing forward on developing new methods, improving the current methods on how we are developing the learning materials, and also different materials to different products for us to be able to support this idea or this dream that we have on how to support the visually impaired and blind children in their learning. So moving forward, I would like to share our current developments. So over here, you'd see that, for example, this book over here. Okay, you may be wondering, this looks very simple. Yes, this is a book that can produce some sound, but the challenge here is like, if we want to convert it, currently, if you notice, is that there are two languages. There's English, there's Chinese, and there's the images. So if you just simply throw it into an OCR, one of the language, for example, it could be converted correctly, but then the other language would be a garbage value. So right now, one of the projects that we're developing right now is that how do we have an OCR that detects multiple languages and converts them correctly at the same time? So aside from that, as we're also developing the editor already. So what we wanted to have here, I know there's one in Germany right now, but here in Asia, we're currently the first one who was actually developing this kind of editor of how are we going to edit images to make it much faster for the users to create their own tactile materials. Yeah, this is just a demo, but we're working on it right now. Next would be, for example, this painting. This is actually a painting. Right now, you are only seeing like, okay, it's what's this painting? It's a painting of Mount Fuji. And if you look at it, the clouds over here, this is actually a tactile photo where you could actually touch and feel the clouds. You could feel the mountain. You could feel the snow over here. So for us, it doesn't look that nice. But then if you add the colors on top of this tactile painting, how would it look like? Then here is it. Here is how it looks like. It's so amazing if you really feel it. If you have it on your hands. This is a famous painter, Katsushika Hokusai. So this person is a very famous painter long time ago, and this is one of the famous paintings that we converted into tactile images. This is in support with a machine printer that we have from Japan. So we're currently partnering with a company in Japan to develop this new tactile materials. So the dream that we had in the past, what I really wanted is it started like for this kind of story. So if you see in this image, you have this young lady over here looking at the ship from far away. Okay, for us, yes, we can see the ship, but let me ask you, if your friend, this lady over here, if she's a visually impaired and blind, how do you tell her that there is a ship right in front of you? It's impossible, right? So these are like some things that really started to draw my attention to how are we going to let them be able to feel, to see these objects in their own way. So one thing that we could do is we need to have a model. So we need to have a big model for them to be able to feel, oh, this is how the ship looks like. But it's not every time that we can just buy a model and then for them to be able to feel of how that object looks like. So what we want is like, what if they could just go, if they're outside, they can just scan their environment. So what happens here? Okay, for example, if they have a device, before we're looking to like putting on a white cane, but it's a bit challenging because we want it to be very small. But what if they have this mobile phone on their chest, tied up on their neck, and then they just scan the environment? If they could scan the environment and then, okay, it says that there's a cup on the table. I want to take a note of the cup. And then going back home, I want to touch that cup again. This cup is very special to me. So what he could do is like, what we wanted to do is that they would be able to touch and feel the cup virtually. So right now we're thinking a lot of things talking about the meta thing. So, but here what we wanted to do is that how are we going to let them feel objects virtually so that they could have a memory? So we started to have this idea when I was talking with a friend who is visually impaired and blind. He's actually normal when he was born, but he started to go blind when he was in college. So one thing that caught my attention, that one problem that he mentioned is that there was one time that he had the chance to go abroad. Just imagine, it's not convenient for them, just go around alone, and what more if they could already go abroad? So he was able to go abroad, and then he was able to go to Malaysia, and there was this tour, and then all he can do is just listen to this audio tour. But then going back to his home country 10 years later, it's very hard to remember all the things that he experienced. Yes, for visually impaired and blind people, their hearing is maybe 10 times or more better than us in terms of remembering things. But still, you don't have anything to recollect that experience. So that gave me an idea. So what if they could scan their environment and they could go back home and feel and touch the objects that they have encountered. So this is one thing that we wanted to build right now. This is a platform that we hope to build, and hopefully in the future, there are like teams that we could work together on to make this dream a reality. So what are we doing right now? So we're looking into currently devices which has a depth camera. We started with an Intel 435i. So this is a camera which has an RGBD. Right now, if you have an iPhone Pro Max or something like that, that kind of like camera, which is a LiDAR, which can take in point cloud data. The point here is that you need to be able not to only capture images, but also to capture the point cloud. So the point cloud data over here, what we have now is that we can measure the depth. So we know how far an object is, how it looks like, and so on. So here the idea that we have right now, and I hope that we could also develop together, is that we have this RGBD data. So we have the 3D depth, and then you separate the RGB image, and then we first detect, again, the object detection. What is this object? So from the depth data, we get the point cloud data, and then combine these two to make it a mass point cloud. So right now we have the depth, we have the RGB, we mass it together, we do the 3D point cloud registration, and then reconstruction. So aside from that, this is the same process as the one that we had in the previous part of the presentation, where we convert what object is this. For example, this is a dog. So this is one thing that we're really working on. We actually have the prototype for this one, but we want it to be further improved. We want them to be able to have this kind of technology wherein they could scan and then keep images converted in the cloud. And then this one, what we could do, the easiest one that we have right now is to 3D print it. So it's like 3D printing it. Yes, they can touch it already. So this is the first step. We could have this data converted on the cloud using AI cloud computing, and afterwards printed using 3D printer. So moving on, it's like you think, okay, this is still a bit limited. So what is it that I really wanted? What I want is to incorporate haptics. I'm not sure if how many of you have encountered about haptics, but haptics is being able to feel the things that you touch. Okay, so for example, I have a bottle here. Okay, I have a feeling when I touch this one, there's a feedback. Okay, it's like there's a response. If you're using your iPhone and it vibrates, okay, there's a sense that I feel something, it's vibrating. That is haptics. So what you would need here is not just your hands, you'd need a tactile sensor, you would need a feedback. So what if we have this kind of feedback? What are we looking at? So here are some of the research currently available right now. So there's like Braille mobile communication where they could feel using the gloves. They could feel there's a capacitive touch sensors, there are vibration motors, so that they could feel the Braille, they could feel the things. And then this one is made by my friend. So currently, this one thing that we're looking into is like, what are you going to do? So you are able to feel the things. So you move like your hand over here. Okay, there's it's like the letters over here. Then you could feel there is something. There's a pin. They're actually using this kind of Braille pins to be able to feel out there's an object over there. So in a virtual environment, just what I mentioned a while ago, what I wanted to do right now is like to bring things that they scanned, converted, and then they could just use these gloves to be able to feel the things, whether you are in Taiwan, in Singapore, the Philippines, Malaysia, no matter where you are in the world, you would be able to easily share not just images, to be able to share objects, to let the visually impaired and blind children or people from a different country get a feel of the things from your own country. So this is something that I believe is still ongoing worldwide, but I believe the future is here. And this would definitely break the barriers, not just in terms of educating visually impaired and blind children, but also in how we do a lot of different transactions. So there's different kinds of technologies that are being used. This one is made by ETH Zurich. So they have these mini actuators where you could feel the force of being able to handle objects, to be able like feeling the touching the object itself. This is part of like what I shared in the previous slides. And then this one uses a string to pull it. This one's like determining the flex. This one's like has a muscle, to restrain your hand, and so on. There are several commercial products right now, like Haptics, Haptx. You can search that in Google later. There are a lot of this kind of different of haptic gloves right now, but these are still very huge. But I believe that the future is here right now, putting the world on your hands, in our hands. So here are our partners. We're very thankful to the Ministry of Science and Technology, currently the National Science Council of Taiwan, Ministry of Education. And then here are our partners for Taichung School for the Visually Impaired and Blind, and so on. In the Philippines, in Japan, our partner is Sinca. In the Philippines, we have Del Sol University, Manila CIT, and USJR, and Resources for the Blind in the Philippines. So in conclusion, there's a huge gap for the development of learning materials for the VIBs. So it depends on where you are. Some countries are more advanced, they have a lot of different methodologies to provide these learning materials, but it's still a work in progress. Many people are focused on how do we provide safe mobility. But now looking into is like, what I want is like, how do we provide them a better learning environment? Second is, how do we break the barriers in education and vocational training? Because what I've shown you a while ago, it is not just for learning, not just for education, but to be able to provide them vocational training. Because as I mentioned in the UN SDG, we're trying to provide inclusivity. We wanted to have a platform for them to be able to learn like others, and for them to also be able to do some jobs that usually it's just all us normally people that are doing certain types of jobs, because I believe they're also very smart, they're very keen, they have the talent, they just need the proper training materials. Next is, how do we utilize AI cloud computing to convert not just images and different types of materials, and preparing this platform that we have shown you today. Next is, I would like to call on co-development of the learning and training platform, because as a team, we're very limited. But with the resources worldwide, I believe what we can do together is very huge. And we can bring the world not only to their fingertips, but also to our fingertips. With that, I'd like to thank everyone, and we hope that we can experience the world at your fingertips. My name is Dr. Aaron Raymond C., and thank you so much for listening to my presentation. The floor is open for questions.
Wow, thank you very much, Dr. C. That was really impressive. And this is a really good example on how we can utilize technology, AI, for the betterment of the society. And as you mentioned, it's for education, reducing inequality, and to promote inclusiveness. So that's a really, really good project. All right, so thank you again. Now we are open for questions and answers, comments. So if you, to our audience, to our participants, if you have any questions, please feel free to use our Q&A option in Zoom, or if you want, you can also chat. But to start our Q&A, this is actually a question for you, Dr. C, on how did you start your interest in helping the visually impaired and the blind?
Okay, thank you so much, Maria, for this question. So it actually started when we were like trying to search for like this certain research topic. So we saw there's like this in terms of mobility. So we started in looking into how do we support visually impaired and blind in terms of mobility. But then there was one time I visited Cebu in the Philippines, and I met with this visually impaired and blind teacher, and he told me his story, the one story that I also mentioned a while ago, and he was able to travel, and then he showed me the learning materials that they have back in the Philippines. So it's like it made me think like those materials, like it's like fixed. There's nothing that they can do. They can just rely on the publishers. And with that, we were thinking like, how are we going to, let them to be able to experience? Because I'm in Taiwan right now. There are things that is like available only in Taiwan, but then there are only things that only available back home in the Philippines. So it's like, how are we going to have a platform to share these different types of things from different countries? So a while ago, you saw that the guy with a cane, and then it can scan the environment. That was what we were planning in the past. It's just the challenging part is, how do we complete the gloves? How do you develop the virtual environment for you to be able to feel? Because, for example, this cup is over here, but I want to feel this cup even if it's not here. So it's like, I can feel it even if it's not there. So this was what I really wanted back in 2019, when there was still no meta. There's still not much of this haptic gloves are going around compared to what we have right now. So this is what we wanted. So that's how we really got interested on, wow, there's a lot of things. Because people, if you look into the different researches, you would see a lot on how to provide safe mobility. But if you try to look into using AI, using technology in developing learning materials, there's very limited amount of research on this field. So that's why we're looking into how. But then if you think about it, education is equally, if not more important than the safe mobility for in terms of their career development. Yeah. Thank you.
Yeah. Thank you so much. Another question is that, since you mentioned earlier for the TikTok, the main goal really is for teachers to be able to have this platform, this capability to actually develop learning materials for VIB students. Have you conducted like some sort of survey or assessment among the teachers on how they find this platform as to help in their in teaching activities?
Yeah. Okay. Thank you so much, May, for that question. Yes, we actually did, but I have a video, but it's in Chinese, so I won't be able to share with you. But one thing that they mentioned is, like, for example, the current tactic system. The things that we are trying to improve right now, for example, is it depends. Like I mentioned, there are different levels of visual impairment. So for those who were blind later in life, like for example, they got blind around maybe 6 years old or later, they may have a bit of a sense of how things would look like in the outside world. But for those who were born blind from birth, okay, like for example, let's use an example. How do you draw a cloud? Right? Usually we draw like a cotton fluffy thing. That's how we draw a cloud. For us, when we see it, we know that is a cloud. But for those who were born who are visually impaired from birth, they don't know what that is because they haven't seen a cloud or how it looks like. And then for them, they also mentioned that if it's too complicated, like for example, if you draw something too complicated, they won't be able to understand those kind of images. So how are you going to simplify those images to make them easier to be able to be felt, because they're just using touch, to be easier to be felt, and then to avoid confusion. So this is actually what we are trying to do right now, this kind of improvement. And I wanted to use AI. How would you like, okay, if you detected these images, how would you simplify it into a simple image that almost any visually impaired and blind person would be able to feel? Yeah.
All right.
Okay.
Thank you for that. And that's actually related to the question of Joe about the difference between those who were born blind and those who were just the blindness occurred during life. And that's also related to a follow-up question. Aside from the differences between these two groups of VIBs, were you also able to assess like the difference, or if there's the impact of the output of this platform compared to just using the traditional learning materials? What's the difference between using this and the traditional learning materials?
Okay. Currently, because of during the pandemic, it's like we got very limited testing opportunities. But the thing here is like, I think what we are going to be able to do in the near future is, because in the past we started with 3D printing, but now we have this machine right now, we have this device right now when we could easily produce the learning materials that we are producing online. So I think the difference right now would be it's easier for us to customize, easier for us to print and to prepare the materials compared to the one in the past. And I think in the future, we do hope that to have more assessments on this type of materials. Yeah.
Yeah, thank you. And another question is on the current project that you are doing. You mentioned a while ago about the gloves, so the wearable. So I just want to clarify this. So once that's the goal of this project is that once we have the gloves developed, it means that the VIB using the glove would be able to actually feel, even without the model, the 3D printed model, the VIB would be able to actually feel the texture, the shape? Is that the goal of the project?
Right, correct. That's the goal of the project. So we would be starting with like to be able to feel the shapes, to be able to feel the stiffness. But in terms of the texture, that's much further in the future, because it's really more challenging to deal with the texture. But for now, the shape and the stiffness of the object is something that we are really looking into.
Wow.
Yeah.
And do you also have any plans of incorporating audio? Like, for example, aside from the haptics?
Yeah, I think this one is something also we can easily incorporate. It's like putting sounds on the different objects, because if they're going to be using a computer, this is something that can be easily incorporated. Thank you.
Yeah, that would really be great. So thank you so much, Dr. C. Do we have any more questions from the audience? No more? All right, but Dr. C, you mentioned earlier that you are actually open for possible collaborations.
Yes, we're looking into possible collaboration, so we're open to that. Hopefully, like maybe in the future, there are teams that could help us also, that we could help them, we could help us, like mutually developing this platform. Because what I envision is that we have this platform in Asia. It's like it's going to be cross country, where the development is being done and could be done in different countries, but then we could produce products that would be customized based on the needs of a certain country. Because right now, for example, yes, I'm in Taiwan, but some of my developers are actually in Cebu. So it's like we're collaborating with them, and then we're looking into like, what if we can connect Philippines, Taiwan, Thailand, Singapore, Malaysia, Vietnam. So if we could have this platform, so that the things that we develop is not just going to be for single purpose, that it could be customized based on the needs of the local community also. Yeah.
Yeah, that would be great. And also that would also promote cross-cultural learning.
Yes.
Because the things that we develop or the things that we have here in the Philippines, there's a possibility that VIB students from other countries would we actually be able to learn from them. So that's really a good opportunity as well for cross-cultural learning. All right. So I think we have no more questions right now. I would like to thank you again, Dr. C, for the very wonderful webinar lecture. It was really, really interesting. And again, as I've said, this is a really good example on how technology and AI should be used today, to help our colleagues or people who have special needs. So we really thank you, and we salute you and your entire team for doing this project. So thank you very much.
Thank you also for inviting me in this webinar.
All right. So before we end, I would like to invite everyone to our next webinar. It is actually on multimodal data in CSCL. So on your screen, you see here the details of the next webinar. So if you're interested, we hope that you would also attend and register for this next webinar. All right. And of course, we would like to hear from our attendees. Your feedback is really important to us so that we would know on how we can further improve the webinar series of the Asia Pacific Society for Computers in Education. So we would like to invite you to please fill out our feedback form. The QR code is in your screen, and we look forward to get your feedback. All right, so I think this ends our session for today. Once again, first, I would like to thank the Asia Pacific Society for Computers and Education. Of course, our speaker, Professor C. And of course, we would like to extend our thanks to your entire team for your project, for doing this for our society. And of course, we would like to thank our participants, our attendees for your time. And we hope that you enjoyed our webinar for today. And we will see you in our upcoming webinars. Thank you again, everyone. And you have a nice day.
Bye, everyone.
Bye, everyone. Thank you.